Okay, so moving on to question 6. A linear sequence starts with the 5th and the 8th term, also it starts with this. The 5th and the 8th term have values 35 and 59, work out the values of A and B. So you could start by finding the nth term rule for these, which actually is the second question, but given that it is the second question, let's maybe move it on. So we're up to here, so this is the 4th term, so the 5th term will be A plus 9B, and then the 6th, A plus 11, the 7th plus 13, and then up to 15, so A plus 15B. Okay, so then we'd make a statement that's true. A plus 9B achieves 35, and A plus 15B achieves 59. Do little subtractions, and the A's disappear. 15 take 9 is 6, and 59 take 35 is 24. So then B equals 4, and if B equals 4, going back maybe to this one, 9 times 4 is 36. That's not, yeah, it is maybe equal 35, so A equals -1. Okay, so now we want the nth term of the sequence, the nth term rule, so we have to answer the question. So don't change the questions you would normally answer. It's a linear sequence, okay? So what does it go up in each time? It goes up plus 2b. So what would you normally say? Well, you'd normally say, oh, it's the 2b times table that we're going to liken it to. So we'd write 2bn, okay? Because like for the first term we get 2b, for the second term we get 4b. What's my adjustment? Well, for the first term, if I put n equals 1 in, I'm getting 2b, but I want a plus b. So I would have to take away b and add on an a. Okay, let's see if this works for the second term. So I'm expecting a plus 3b. So if I put n equals 2 in, I'm going to get 4b, take away b is 3b, and then add a, which gives us exactly what we want. We could tidy this up, I guess, and write it as b 2n minus 1 plus a. Okay, and then of course this in its own right makes sense because we have a in every term, and then if you just looked at the pattern for the b's, it's 1, 3, 5, 7, 9, 15, which of course is 2n minus 1, so you could have gone about that any which way. Okay, so for question 7, so should the difference between the nth and the n plus 1th term is given as so. There we go. So this is the nth term. If I want to generate the n, if I want to generate the second term, I put n equals 2 in here. So if I want to generate the n plus 1th term, I just put n plus 1 everywhere I see m. Okay, so that's the nth term. The n plus 1th term would be 3 lots of n plus 1 over n plus 1. Okay, so let's simplify that. So that equals 3n, 3 from the bracket, add 1 plus 4, n plus 1. So what's the difference between the nth and the n plus 1 terms? Now I'll say at the start here, depending on which way around you take them, you can end up with a positive or negative version of this. Now given it says difference, it's just the magnitude of this number that matters, not the sign that you get at the end, because we don't know whether it's an increasing or decreasing function. Okay, sequence I should say. So we will do 3n plus 1 over n, the nth term, minus 3n plus 4 over n plus 1. So we need a common denominator, so that common denominator is going to be n plus 1. Wouldn't bother expanding it, doesn't achieve anything, and also that's what we want in the answer. So what's happened to this one? It just got n plus 1 times bigger. The numerator or the denominator does the numerator all as well, so we've got 3 n plus 1 times n plus 1 minus this one got n times bigger. Okay, so we're going to times that by n, we're going to expand it and we're going to simplify, so I'll just do that up here. So for the numerator on the first one, we'll get 3n squared, and then we'll get plus n plus 3n, so we get plus 4n plus 1 minus all of whatever we get for the second one, so 3n squared plus 4n. So as we can see, these would cancel because you're taking away all of this. So that's a plus there, you're taking it away. So you end up with just 1 over n times n plus 1. Which are the first two consecutive terms with a difference less than 0.01. So you could try this on your calculator, but the question really is, when is this expression here less than 0.01? So you've got 1 over n times n plus 1. When is that less than 0.01? So for a value of n, when you take the next term, which will be the n plus 1 term, and you take them away, when is this less than 0? So, you know, is this easy to answer? Well, perhaps if we just mess around with it. So we write it as 1 over n times n plus 1 less than 1 over 100. Okay, and then we can say, let's write that as 100 has got to be less than n times n plus 1. Now sometimes there's a little bit of an issue with multiplying through by denominators with inequalities here, because we don't know whether this is positive or negative. But here we know that n is always a positive integer, so we're multiplying by positive numbers, so we can say that this would be true. There's no change of sign that's taken place here that would mess it up for us. So then if we just rearrange this, we're going to get n squared plus n minus 100 has got to be greater than 0. So now we've just got to solve this. And I'm going to use my graphical my calculator for that. So we get two answers. We get n equals 9.5 and n equals minus 10.51. Now, normally quadratic inequalities, it matters, like what does the graph look like and blah 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 blah. First thing is we can cross this off because n's got to be a positive number. So actually, and if you did draw the graph, it would look something like this. That would be your minus 10.5. This would be a 9.5. So it all works out. We want values where the graph is greater than 0. So that would be all these values here anyway. So I need to be n greater than 9.5. So I need to be n equals 10. And then, of course, the next term, because that's what we found the difference of. We found the difference of a term, and its next term would be n equals 11. And you can try that on your calculator. I think you get 1 over 110 when you put a 10 and 11 in, but you get 1 over 90. Something like that when you put 9 and 10 in. So those are our consecutive terms. So now we've got the limiting sequence questions. These are actually quite easy. It's just a question of how do we... So when you look at this function, it's very difficult to say what it tends towards. Now what we mean is when n gets really, really big, is there a number that the sequence gets closer and closer to? So on a graph, you see the graph converging towards a particular value. Okay. Now it's difficult in this format for our brains to decide what this necessarily would look like. There's lots of things you can say. You can say, well, the 2 becomes redundant when n gets really, really large, therefore it just becomes 5 over 2, which is 2.5. Another nicer way to do it is to say that we understand what happens to the function 1 over n as n gets large. It goes to 0 because 1 divided by something that gets really huge goes off towards 0, or gets closer and closer to it. So if I can generate these terms within this function, then we can understand better what it looks like. So if I find an equivalent fraction form of this, so I'm going to times the numerator and denominator by 1 over n. So that would give us 5, because the n's would cancel, plus 2 over n. So if you like, I've divided the numerator and denominator by n, maybe a nice way to think about it. And then if I divide by n again, I get 2. Okay, so I've divided by n top and bottom, so it's equivalent. So now what happens? Well, as n goes to infinity, then this term here goes to 0, and therefore it goes to, the sequence converges to 5 over 2. Okay, nearly there. I think in the third video I'm not going to explain all this in 50 seconds. So here's a sequence of odd numbers, and so I'll start these, have these two in a third video.